Section 5.5 and 5.6 is going to be over finding all the real zeros of a polynomial. Let's look at an example we've already looked at. Let's look at 6x to the third plus 19x squared plus 2x minus 3. And let's say that x plus 3 is a factor, and we want to find all zeros. Well, if we know x plus 3 is a factor, we learned last time that if x plus 3 is a factor, then x equal to negative 3 is a 0. Okay? Then, if I know a 0, I can simplify the polynomial by doing synthetic division with it. So if we do that, we get 6x squared plus x minus 1. If I set that equal to 0 and solve it, that will find the other two remaining zeros of this polynomial. Okay, so we can use the quadratic formula if we want. So we get negative 1 plus or minus the square root of 25 over 12. So we get that. So negative 1 plus 5 is 4 over 12, or 1/3. And then negative 1 minus 5 is negative 6 over 12, which is negative 1/2. So, to answer the question, what's all the zeros? Well, we were given negative 3 is a 0, and then we found, by simplifying it, that 1/3 and 1/2 was a 0. Now, that shows that if we have some known zeros, we can simplify it down to a quadratic. If we can at least get it to a quadratic, we can solve it from there. Let's look at another example. First, let's talk about a theorem. Let's do something called the complex conjugate theorem. The complex conjugate theorem basically says if a plus bi, a complex number, is a complex zero of a polynomial, then its conjugate, a minus bi, also has to be a 0 of that polynomial as well. Okay? So, what does it mean for it to be a complex 0? Well, a 0 is anywhere where the polynomial, the x values where the polynomial equals 0. So, in certain cases, that might be a complex number, which we can it's still going to be a 0 of the polynomial. It's just not going to be an x-intercept as well, because you can't have a complex x-intercept because you can't go to the x-axis and just point at it. So let's say I have this polynomial, and 1 minus I is a 0. And we want to find all zeros. Well, if 1 minus I is a 0, what also has to be a 0? Its conjugate, 1 plus I, has to be a 0. Okay, so now I have two zeros. So I showed you last time that you can do synthetic division with complex numbers. So let's do that to simplify it down. Okay, now let me show you something cool with the calculator here. If we hit mode on our calculator and scroll down here, we can change it to complex mode. So now, if I go to do multiplying these complex numbers, it's a whole lot easier with the calculator. So if I bring the 1 down and then 1 minus I over here, add just the real parts, it's going to be negative 6 minus I. The next thing that needs to go in this position here is 1 minus I times negative 6 minus I. Now you need to use this little I down here. That is the imaginary unit I. Don't use this I up here. That's actually just the letter I. And it will go ahead and put it in complex form for us because we told our calculator to be in complex mode. So if we do that, we get negative 7 plus 5i. Add just the real parts. 18 plus negative 7 is 11. And plus 5i. So then we need to do 11 plus 5i times 1 minus I. And we get 16 minus 6i. Add just the real parts. Negative 22 plus 16 is negative 6. So then we need to do negative 6 minus 6i times 1 minus I. We should get negative 12, and we do, because we knew it was a 0. So then now, once we've simplified it that far, we can use any other 0 we know, which we know since it's complex, to simplify it a little further. So we get 1 plus I. The imaginary parts go away, and the real parts is negative 5. It's going to be negative 5 minus 5i. Imaginary parts go away. 11 plus negative 5 is 6. 6 plus 6i, everything goes away. So I'm left with x squared minus 5x plus 6 equal to 0. And that's what we need to do to find the other two zeros. And look, it factors. X minus 3, x minus 2. So we get 3 and 2. So, to answer the question, what are the zeros of the polynomial? 1 minus I, 1 plus I, 3 and 2. Okay? Now, let's say I just give you this. I say, if f of x is x to the 4th plus 5x to the 3rd minus 2x squared plus 60x minus 168, and I want you to find all zeros. How do I find all the zeros if I'm not given anything? Well, the calculator is awesome because the calculator, we can look at the zeros on the graph and use those to simplify it down. Now, this is a 4th degree. I need at least 2 zeros to take it down to a quadratic. Just like I did in this example right here. I had 2 zeros. I took it down to a quadratic. This example up here, I had 1 0. I took it down to a quadratic. So if we're at 4th degree, I need 2 zeros to take it down to a quadratic. So let's graph it first and look at it. We got x to the 4th plus 5x to the 3rd minus 2x squared plus 60x minus 168. Okay, now this graph is really big, kind of blown out of proportion, but you can see right here that it crosses, it looks like negative 7 and looks like positive 2. If we go to second calculate, you can see we have an option to actually find zeros. Now it's going to ask for a left bound and a right bound. If you look right here, I'm going to want to get to the left of this and to the right of this. It's going to be hard to see because this is so steep. So if you watch this, it's going to bounce up through there, and I want to make sure and at least get to the left of that. So that's obviously going to be to the left of this. That's nearly here. Okay, so then if I watch this again, I want to get to the right of it, and that's down here. And it finds that to be -7. So I know for a fact that -7 is a 0. Okay, if I do that again for this one over here, again, I'm going to watch this guy, and that looks like it's at 2, so let's be obviously to the left of 2. Okay, so that's obviously going to be to the left. If I scroll to the right, that's going to be obviously to the right. That's nearly to 3. And we find it to be 2. Okay, so I have proven that on the calculator. But see how this is a 4th degree? We learned last time we have as many zeros as we do degrees. So I need to find 4 zeros. I found 2. I'm halfway done. But I can use these guys to simplify this down to a quadratic. I can do that with synthetic division. So let's do that. I'm going to use the -7 first. Oops, that's 168, not 128. So we get 1, -7, -2, 14, 12, -84, -24, and -24 times -7 is 168. Okay, I've simplified it a little bit. Now let's simplify it again with the 2. 1, 2, 0, 0, 12, 24, 0. So what I'm left with is x squared plus 12 equals 0. That's easy to solve. I don't even have to use a quadratic formula. Square root both sides, and this is going to be 2i square roots of 3. And don't forget, we always have plus or minus with a square root. So what is my zeros? Going back up here, we have -7, -2, 2i square root of 3, and -2i square root of 3. Okay, let's do another example just like that. Let's say I want to solve this equation. So this one's not really finding the zeros, it's solving an equation, but solving a polynomial is just finding the zeros, because finding the zeros of a polynomial is setting that polynomial equal to 0. So if I'm given some polynomial, this is a 3rd degree, set equal to 0, finding the zeros is solving it. Okay, so let's solve this. Okay, so again, back to the calculator. Let's graph it. 3x to the 3rd plus 4x to the 2nd minus 7x plus 2. Okay, now right here we can't really tell what's going on. It's really small, so let's zoom in. Okay, as you can tell, it dips below it. When we were backed out, you couldn't hardly tell that. So there's 3 zeros. 1, 2, 3. Okay, now this is 3rd degree. That's 3 zeros. Now sometimes when we use a calculator, they're not going to be very obvious what they are. On the other example I did, it was -7 and 2. Let me find this guy right here. Okay, I'm to the left, to the right, and we find it to be -2.4144. Now we don't really know what that is, so we'll come back to that. Let's go to this one. Let's do the same thing. Going to be to the right, There's to the left and then to the right. And it's 0.41421, so we don't really know what that is either. So let's check this last one. To the left, to the right, and we find it to be 0.6666 repeating. Now we know what that is. Oh. We know that's 2/3. These other two guys we couldn't recognize. We're going to have to get those by finish solving this. But if we have 1 0, since it's a third degree, and we know we can get it to a quadratic by doing synthetic division. So we've got 1 0 by looking over here and finding this. Okay, so let's do synthetic division. Three comes down. 3 times 2/3 is 2. 6 times 2/3 is 4, -3, and -3 times 2/3 is -2, and I get 0. So I have 3x squared plus 6x minus 3 equal to 0. Again, quadratic formula. So I have -6 plus or minus the square root of 6 squared minus 4 times 3 times -3 all over 2 times 3. So I have -6 plus or minus the square root of 36 plus 36 over 6. That's the square root of 72. And the square root of 72 is 6 square roots of 2. And then I can divide everything by 6, which this will give me -1 plus or minus the square root of 2. So to answer the original question, to find the zeros or the solutions, x equal to 2/3, -1 plus the square root of 2, and -1 minus the square root of 2. Okay, that's where we'll stop.